before we can do any line integrals, I need to teach you how to be able to drive a particle through 3D space along a particular path. So for example, how would you drive a particle from A to B? So it's starting at 3, 4. So and then it goes straight up from -2 to 5. Remember, the vector itself goes straight up from -2 to 5, but we actually want the position vector. So the position vector is from the origin to here. So as the particle is moving, you always know the position vector. We're after the position vector. So so to create this, we know that I hat and j hat will always be at 3, 4. So the position vector is given by this. It's always going to be at 3, 4 because it's going straight up. And then to create your vertical movement, you would just stick t in there, t, k, hat, and then it ranges from -2 to 5, -2 to 5. So this thing here would be your position vector. So as the particle is moving up, you always know the precise location of the particle. Remember, you're after the position vector, and this is an alternative way of doing it. You can always change the speed at which the particle is moving up by sticking a 7 in front of the t. So here t ranges from 0 to 1. So by the time gets to 1, you can see that 1 times 7 would be 7, and then take away 2, so that would be at a height of 5. At a height of 5. When t is 0, put 0 into here. This would be 0, take away 2, it would be -2, so the height would be -2. So two ways of setting this up. This way, there must be loads of other ways. Okay, next example. So let's say you want to drive a particle from 3, and then it moves along a circle. It moves along a circle. So this is +3, and it ends at -3, and there's no movement in the y direction. So when you set up your position vector, there you've got your I hat, j hat, and k hat. There will be no j hat movement because it's not moving in the y direction. So we can ignore the j hat. So now imagine this is your face here, looking at it from this direction. So the x-axis would be on the right hand side, and straight up would be your z-axis. So this is the movement in the height. Now you know from parametric equations we can always draw a circle like this by using cos t and then sine t in terms of the height. Hang on, let me think. Z would be k hat, and then this would be I hat. So you can think of it like this. But then that will give you a circle of radius 1. But the thing is, you want the radius of 3. So stick a 3 in front of it. So now you've got a particle that moves in a state your t. T would be from 0 to pi. So from t would be from 0 to pi. That's how you would drive a particle from here to here. Now so this would be your position vector. This would be your position vector from 0 to pi. So now let's suppose you want the particle to start at A here and then ends at B. So it's going in the opposite direction. How would you come up with a position vector to drive the particle from here to here? Think about it. Press pause and think about it. Okay, so to do this, well, if you hang on, so you know it's got to be of this form. Cos it's going to be very similar to this. Hang on, I hat plus 3 sine t k hat you know it's going to be very, very similar to this. But the thing is, when t is 0, hang on, t is going to be something like this. When t is 0, you want the particle to start here. So you want the particle to start here and then go in the opposite direction. So if you do this, hang on, see this t here. If you replace this with pi minus t, there. If you replace it with this pi minus t, hang on. So this is a trick, pi minus t, and then stick an I hat in there. So now when t is 0, you can see that cos pi will start here, cos pi, and then by the time it gets to pi, pi minus pi will be 0. So by doing this, you're really starting from here, and then eventually you get to here, and then change this as well. So this would be pi minus t. So well, in short, your position vector would be given by this. If you want to go the other way, it would be given by this. So jump to a 3D graphical plotter and verify this. So we're going to jump to GeoGebra. Punch in your curve. So this is your curve here, and then add your particle. So this is our particle here. I hope you can see it's right there. This is our particle, and when the particle is at b is our t in a way. So when b is 0, you can see that it starts at -3, and then as you move to pi, you can see that the particle is moving backwards. So by the time you get to pi, roughly 3.1 something, so 3.1. So you can see it will end up here. Okay, so in the next video, I will show you how to drive the particle from 3 to 2. Okay.